All right, good morning, everyone. My name is Aliya Bein, and I'm excited to share the findings from my research about the regeneration response of tolerant hardwoods to beech bark disease vegetation management. So to provide a little bit of background, American beech, or Fagus grandifolia, is an important species that forms a major portion of trees in eastern North American forests. It is also a mass tree and a keystone species, as it provides nutrient-rich nuts that many wildlife species rely on, such as marten, deer, black bears, and more. Unfortunately, the beech tree population has been heavily affected by beech bark disease, which is an insect fungal complex caused by the beech scale insect, which feeds off the photosynthase of trees and allows two pathogenic fungi in the genus Neonectria to enter and infect the vascular system. So the disease has been in Canada since the 1890s, but it's relatively new to Ontario as it's only been here for the past 2 decades. And in the killing front, between 50 and 85% of trees infected by beech bark disease will result in mortality, which can occur as quickly as 3 to 6 years after the scale insect is detected in an area. So the loss of this significant component of beech poses both economic and ecological issues for the forest. But it is the long-term effects of beech bark disease that are a major concern for forest managers, as it can drastically change the structure and species composition of the forest. And this is because beech trees are first very shade tolerant, so they provide a very intense shading in the understory, but they also regenerate in 2 different ways, sexually from a parent seed or vegetatively from root suckers or stump sprouts. So the mortality of mature beech from beech bark disease and as well as root injury from logging activity can result in root or stump sprouting, which leads to beech saplings forming beech thickets that are able to outcompete other hardwood species, such as sugar maple. So since beech bark disease has been here for decades, you might think that we know how to manage these negative impacts, but it's a very complex and long-term issue, so with no obvious management strategies. So several methods have been studied on how to control this dominant beech regeneration, such as variations in harvesting, mechanical cutting, and chemical treatments. So promoting the regeneration of other species through variations of a regular shelterwood or partial harvesting has been suggested, but increases in harvesting has also been shown to trigger more beech regeneration because of the increased root and stump sproutings after the treatments are applied. So for these reasons, harvesting alone cannot be the only regeneration technique to reduce beech regeneration. So more research has been focused on mechanical cutting and chemical treatments. So for my research, I wanted to find out which treatment is more effective for reducing the proliferation of beech regeneration between a mechanical brush saw treatment and a basal bark application of the herbicide triclopyr 6 years after the treatments were applied. In doing so, I also wanted to find out if the treatments had any effect on sugar maple regeneration, which is a much more economically and ecologically desirable species in the forest. So our study took place in Bancroft-Minden Forest, which is part of the Great Lakes St. Lawrence Forest region and is found right below Algonquin Provincial Park. The average basal area of our study site before it was harvested was 23.4 meters square per hectare, and that was made up of approximately 63% sugar maple and 13% beech. For our treatments, each plot was first harvested as a uniform shelterwood seed cut, and our mechanical treatment was a manual motor brush saw that removed all beech smaller than 20 centimeters in basal diameter. And our chemical treatment was a basal bark application of triclopyr, and this was applied to all beech between 1 and 20 centimeters in basal diameter. And from now on, I will be referring to mechanical as brush saw and the chemical as basal bark. And to give you all a little bit more of a temporal scale of the research, in 2016, 54 experimental plots were established, and this is when we did our first data collection. So this is our pre-treatment measurement. The harvesting occurred from summer through October 2016, with a smaller portion that occurred from September to October 2017. And our basal bark and brush saw treatments were applied from August to September 2017. 1 year later, in 2018, there's another data collection for our 1-year post-treatment measurement. And this past summer in 2023, I was part of the data collection for the 6-year post-treatment measurement. And in our study, we distinguish regeneration in different size classes to allow us to better understand the future composition of the forest. So we classified them as small, medium, and large regeneration. For my statistical analysis, I compared the pre-treatment data with the 6-year post-treatment data to understand how the treatments affect regeneration through time. I used a series of mixed generalized linear models fitted with a negative binomial distribution. And I use this model because it's beneficial when analyzing non-normal data for ecological research because it accounts for random effects. And in our research, we need to account for random effects because we're following the same plots through time. And all graphs and statistical analysis were done in RStudio and Excel. So now to get into the results, we'll be starting with my first objective, which is to determine the treatment effect on beech regeneration. And just to preface, I will be showing the results in a little bit of a non-conventional order, just to make the reasoning behind it make a little bit more sense. So I will be showing them from large to small to medium. So first we have the results from the large beech regeneration. And just another note that for all the graphs I'm showing today, the letter groups represent the significant differences within each year. For example, the green letters will demonstrate if there are any significant differences in before the treatments were applied. So for large beech regeneration, we can see that there was none. While the blue letters will demonstrate if there are any significant differences between the treatments 6 years after the treatments were applied. And this, we're expecting to see some change. So for large regeneration, the brush saw and the basal bark treatments decreased from pre-treatment levels, while the harvest control increased. So by year 6, large beech regeneration in the brush saw treatments was reduced by 88%, while basal bark reduced large regeneration by 62% compared to pre-treatment levels. However, we found that there was no statistical difference between the treatments, and both were effective for reducing large beech regeneration compared to the harvest control. So this finding is not very surprising based on the results of previous studies that have demonstrated the success of both brush saw and basal bark treatments. For example, Ostrovsky and McCormack in 1986 found that basal bark applications of triclopyr reduced advanced beech regeneration by 87% 2 growing seasons after it was applied. As well as there are several studies by Neeland et al. That have also found brush saw treatments are successful and have demonstrated a high degree of control over the understory beech, as well as high mortality rates 1 year after the treatments were applied. So now for our small beech regeneration, there was a decrease in all treatments. So by year 6, the brush saw reduced small beech regeneration by 20%, while basal bark reduced regeneration by 72% compared to pre-treatment levels. So we found that basal bark was more successful at reducing beech regeneration compared to the brush saw treatments. And this is probably because the decline in regeneration in the brush saw more or less plateaus after 1 year post-treatment. And as we previously discussed, there are several studies that have found that beech regeneration may be higher in more intensive mechanical treatments because more root or stump sprouts will develop soon after the treatments are applied. So instead of decreasing through time like the basal bark treatment does, new beech seedlings keep growing into this new size class. Now moving on to our medium beech regeneration, the treatments actually had the opposite effect on the medium compared to the small and the large size classes. This is why I'm showing it last. So instead of decreasing over time, medium regeneration increases in all treatments, even after it was essentially eliminated in the brush saw and the basal bark plots 1 year after the treatments were applied. So 6 years later, there was a spike in all treatments. And these increases are likely from the small regeneration from the 2018 measurement that are recruiting into the medium size class by 2023 because of this 5-year age gap. Regardless, we still found that the increase in the brush saw by year 6 was more significant than the increase in the basal bark treatment relative to their pre-treatment levels. As a result, the basal bark application of triclopyr was found to be more effective than brush saw, despite also showing increased levels of beech regeneration. So now moving on to our second objective, which is to determine the treatment effects on sugar maple. So here we want to be promoting sugar maple. So seeing increases in regeneration is a good thing. And again, I will be showing the results in a more intuitive order from small to medium to large. So the presence of small sugar maple regeneration increased in all treatments, including the harvest control. So according to the results of Hain 2003, when significant portions of beech regeneration is removed, sugar maple survivorship should increase compared to plots with beech regeneration. However, we did not see the significant effect or significant increase in the treatments compared to the harvest control. So we found that there is no difference between the basal bark or the brush saw treatments either. So the increases that we see, they cannot be attributed to a treatment effect. Instead, it is likely that there's more small sugar maple regeneration because the harvest created more light gaps for them to grow in, or because the overstory was dominated by sugar maple. So similar to the results of this small sugar maple regeneration, medium sugar maple regeneration also increased in all treatments as well as the harvest control. Brush saw did have a larger increase from pre-treatment levels compared to the basal bark, with a mean percent change being over 1,000%. However, the number is pretty misleading because the plot started off with almost no regeneration, so any increase would seem large when looking at the percent change. Regardless, we found again that there is no statistical difference between the brush saw and the basal bark treatments. So even though the small and medium sugar maple size classes increased across all treatments, it is likely that a high portion of these stems may not recruit into the next size class. And this is a trend that we see as we look into our large sugar maple regeneration, as it decreases across all treatments. So this isn't really great news because that means that sugar maple survivorship is decreasing through time. However, we found once again that there is no statistical difference between the treatments or the harvest control. So this means that the decline is not related to a treatment effect, but the stand is still not in equilibrium because of other factors that affect stand development. So to summarize our findings and to answer our main objective, which is to determine which treatment between the basal bark application of triclopyr and a mechanical brush saw treatment is more effective for reducing beech regeneration, we found that small and medium beech regeneration was more effectively reduced by the basal bark application of triclopyr, while large beech regeneration saw no statistical difference between the two treatments. However, they are both more effective than harvesting alone. And our sugar maple regeneration saw no statistical difference between any treatment. So based on our findings, the basal bark application of triclopyr may be a more effective long-term solution than the brush saw treatment when considering the small and medium sugar, size classes. Which are important size classes because they will be determining the future composition of the forest. However, it is recommended that decisions for vegetation management techniques are made based on other factors as well, such as cost and environmental impacts. So brush saw techniques are single stem cutting methods, so they are often more expensive and they require more investments in time, equipment, and labor compared to a basal spray. So to put it into context, at our study site, the brush saw treatments cost range between $721 to $1,000 per hectare, while the basal bark treatments range from $360 to $700 a hectare. But environmental considerations are also very important, and chemical herbicides can be a pretty controversial topic. And this is because there's a trade-off when you use a chemical herbicide because it can run down the bark and it may enter the soil and affect other trees through their roots. And although this was not a negative effect that we saw on our sugar maple regeneration in the basal bark treatments, it is possible that other species are more affected or more sensitive to the herbicides. So other jurisdictions have already created policy against herbicide treatments in the forest. For example, in Quebec, the use of chemical herbicides have been banned on Crown Forest lands since 2001 because of its negative effects on major biotic communities. So this research provides a meaningful comparison between two common vegetation management techniques for controlling beech regeneration. But there are opportunities to answer more questions on this topic, such as how often should these treatments occur, and at what point in the harvesting timeline should they occur? Also, our research only looked into how the treatments affected beech and sugar maple regeneration, but it is important to also know how the treatments affect other valuable species, such as yellow birch. And lastly, although we did not find that the treatments had a significant effect on our sugar maple, we still found that the large size class decreases across all treatments, as well as the harvest control. So we need to find out how we should properly establish sugar maple regeneration to ensure its continued growth and succession in the forest. So thank you all for coming and for allowing me to share my findings with you, but I couldn't have done it without the help of the following people. So I'd first like to thank my supervisor, Dr. John Caspseren, for guiding the research process. And a big thank you to my external supervisor, Dr. Eric Searle from the Ministry of Natural Resources and Forestry, for all of his help with the statistical analysis and for all of his support over the past 6 months. And thank you to the rest of the team at MNRF, Elaine, Bridget, and my field partners, Aaron, Nick, and Paige, for collecting the data for the research. And lastly, I'm very grateful to my 2022 to 2023 Masters of Forest Conservation cohort. No doubt you guys have definitely changed my life. And a special thank you to Olivia Hardkey for all of her editing. And a thank you to Charlotte Grieve for keeping me company in Sault Ste. Marie this summer and attending one of our trips to collect data at Bancroft Minden. So thank you. And I'm ready to answer any questions.
Thank you. Wonderful. Eric, are you online to ask the first question?
Yeah, can you hear me?
Yes, perfect.
Awesome. Yeah, thank you. And thank you very much, Aliya, for the great presentation. I actually have 2 questions since we have 14 minutes here. I'll use up a little bit of time. So I've got a very difficult question and then an easier question. I'm going to start with the very difficult question because I like to put you on the spot. And that question is, what are you most proud of during your MFC? I know you've done a lot. And yeah, I'd just like to hear what you're most proud of in the past year and a half.
I would probably say this capstone is probably what I'm most proud of. I'm really proud of all the work that was put into it and everything we did throughout the summer and how much I learned so much from working at the ministry. So definitely this capstone and everything you taught me.
Okay, well, thank you. That was not an trying to solicit praise, but thank you. We're very glad to have you. So for the easy question, I often get approached by people who have small woodlots, obviously crown forest managers on Crown land too, some of whom are on the call, and a big thank you to Bancroft Minden Forest Company for continuing to support this research about what should they do with their beech. Often in these tolerant hardwood stands, there's 30% plus beech by species composition. All of it is likely, if not going to die, then certainly going to decline rapidly in quality over the next decade or so. And there's a huge amount of beech in the understory. So I guess from your research, but also a bunch of the sites that we've walked this summer, some of the conversations you have, what would your approach to managing beech on the landscape be?
I remember one of the first days of the MFC when we were in Halpern, something one of the forest managers said that really stuck with me was that beech is no longer serving its purpose. So it's best to just get rid of what we have. And beech bark disease is a very long-term issue and it's not going away anytime soon. So right now I feel like one of the best strategies is to just try to mitigate as much overstory beech as possible, as well as understory. And I know that sounds like you're just getting rid of the diversity of the tree, but we still need to promote the regeneration of other trees. So right now, I think that getting rid of the beech is probably the best way to go about it.
Okay, and from your research and looking around, what strategy would you employ for the understory mitigation piece?
Personally, if there wasn't environmental considerations, I would definitely go with the basal bark treatment. It's a lot cheaper and it's more effective. Even when we were starting to talk about this in the summer or when I came back, John was asking me what treatment did I observe looked like it was the best one. And walking through the basal bark plots was definitely seemed like the better way to manage the beech regeneration. So I would definitely go with that. And there's also ways to mitigate how much environmental impacts there are from it, just by being careful with the way we apply it to the basal bark and everything like that.
Yeah, certainly with the targeted approach, it's much easier to mitigate any environmental concerns. Yeah, thank you very much, Aliya. Great presentation and excellent job.
Thanks, Eric.
Thank you. Any other questions from the audience? Yes, a question at the back. I'll bring you the mic just so people at home can hear.
So my question is, you showed that basal bark is more effective than brush saw at managing beech regen. Was it effective enough to change the successional direction of the forest away from beech or to make it essentially a commercially viable stand in the future? Like, did you get rid of enough beech regeneration for it to be considered a success?
That's a good question. Let me go back to our large beech here. Yeah, so what we have is, I think with the basal bark and the brush saw treatments, it went from close to like 7 or 8 stems per, this is a 16-meter radius that we were getting the results from. And then it went down really significantly. So I think when you're looking at the large regeneration, yes, it is enough that it's promoting other species and there's more to make it economically viable. It's hard to say about the future composition of the forest because we don't have the data. We don't really know what the long-term future direction is going to be. But also considering the small and the medium regeneration, I do think that we removed enough because they also went down to like two-ish stems per hectare, 2 per 16 meters squared, not hectare. So yes, I think that there was enough removed to make it viable.
Would be still going free, you will report, or would that fall where they would not agree with the law?
And it depends what treatments we're going into though. For the harvest control and the control, beech definitely seemed to be very much there. For our basil bark treatments, I was very surprised to see like the day and night difference of how much beech there was not, because it was mostly, a lot of it was removed and the understory was there was a lot more, I would say, elder, raspberry, and other species that are coming up.
Thanks. John?
Yeah, let me just follow up on Adam's question. Maybe a bit of playing devil's advocate. So looking at that brush saw treatment there, you've got a beech thicket, and you made the point that that's maybe one of the problems with the brush saw treatment. And you answered his question by saying yes, you think it was effective, but could a naysayer say otherwise, that especially looking at these medium stems, you still have a beech thicket? The basil bark isn't much better than the harvest control. Yeah, so you probably, that's probably not a very good question. Let me put it another way. Is there some kind of target that you were aiming for? Like, is there, or have you seen in the literature some target of residual density that's considered sufficient to be able to answer Adam's question?
So in the literature, I was not seeing any residual target except for the harvest, the actual harvest itself. So not any for beech for the regeneration. And in our study, from what I remember speaking with Eric and other people, I don't remember having a residual target for the regeneration either. I think that the medium regeneration is not the best part to look at for a question like this because there is the recruitment and it is the only one that has a very different effect than the large and the small stems. But again, it is a fair point because these will recruit into the large size class eventually. And that means the large size class will definitely have, so this graph in the future, if we did another measurement 6 years from now, might have all those medium stems going into it. So we might see an increase again, which kind of goes back to the questions that I posed at the end, which is how often should these treatments be applied? And at what point in the harvesting timeline is best to apply them? So to properly answer your question, there was no residual target that I know about that they were aiming for, but I still think that the basil bark, it was very effective for reducing the regeneration compared to the brush saw.
Okay. All right. Thank you so much, Aliya. Great work.